The house chosen to be analyzed is a residential two-story semi-detached building that's located in Montreal in the Côte Saint-Luc area. It has a gross floor area of 300 square meters. The energy consumption is extremely high compared to the ones in the neighborhood. The data here shown from Hydro-Quebec indicates that the house uses approximately 29,000 kilowatt hour per year of energy, while houses with very similar characteristics in the same area only uses about half of that. The first category being architectural, the second mechanical, electrical, and the third is renewable energy. We've narrowed them down to 6 throughout our analysis, and we are left with HVAC upgrade, geothermal energy, a replacement of the existing windows, upgrading the lighting, increasing the thermal insulation of the building envelope, and solar energy. The current energy system used to heat and cool the house is an electric furnace paired with an old air conditioning unit with a very low efficiency because it uses old technology. The HVAC system upgrade consists of installing a heat pump and pairing it with the existing furnace. The heat pump is very efficient because it has a coefficient of performance ranging from 3 to 4. HVAC system upgrade could be paired with intelligent thermostat, which basically adapts itself to the homeowner's habits and sets the temperature in consequence. This allows you to save up to 10 to 12% in heating and 15% in cooling. Another alternative would be to use geothermal energy to heat and cool the house by pairing it with a heat pump, similar to our first alternative. But the advantage here is that the efficiency is constant throughout the year. Replacing the windows is also a very good alternative to save energy, as single glazed windows have very low R value and basically lets cold in or heat out during summer and winter. By replacing the windows with higher R value, we would have less heat loss. A significant energy efficiency measure would be to replace the incandescent light bulbs used currently in the house by LED light bulbs, as they use 3 times less energy to produce the same amount of light. They have a useful life of 20 to 25 years. Old houses from the 1950s and 60s typically have a resistance value of R20 for the wall and R12 for the ceiling. These could be easily upgraded to R32 and R18 respectively, and the energy savings are expected to be about 15%. Solar energy has advantages because net metering is allowed by Hydro-Quebec, and you can go earn up to 20% tax credit. A simple simulation shows us that we can save around $600 of annual energy consumption. At this stage, the alternatives that seem the most promising economically are the air-to-air heat pump, the LED lighting, and the thermal insulation. We will be conducting preliminary cash flows for all of the alternatives. We'll be merging alternatives together and narrowing down our choices, and we'll propose a feasible solution from there on.